Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. How are you all students? I hope you all are fine. Now today we are going to have a lecture number 4 of computer, and we were discussing chapter number 1's topic, history of computer, and probably this will be the last class of this topic. And till now we have discussed about 6 calculating devices, and we are going to study 3 early calculating devices. And what was history? History is something we denote with the study of past events. Okay, so this is an overview of the chapter number 1, and probably the history of computers will be the last one. The history of computers continued. Early calculating device is Babbage difference engine, and we are going to discuss 2 machines invented by Charles Babbage, and we all know that he is also known as the true father of modern computing. So he found out the use of gears and levers, because at that time these were the machinery equipments, and these are the mechanical components, means these are the machinery parts. So he used them, and in 1812 Charles Babbage noticed a natural harmony between machines and mathematics. So he found out the relation between maths and machines, and because you know why? Because machines are best at performing tasks repeatedly without mistakes, while mathematics, particularly the production of mathematical tables, often required the simple repetition of steps. What does this mean? That machines are best at working their task. Means if I want to run, or if I want to perform any task in a computer, it can do thousands of times, but if I want myself to do that, I will not be able to do that, because that's my capacity, or my capability is limited. Okay, so mathematical tables, we all know these are a simple repetition of steps. How do we are going to calculate the next number in a table? We just simply add that number to itself. So these are the simple repetition of steps. So what he did, he just found out the problem, that by applying the ability of machines to the need of mathematics. So his first attempt at solving this problem was in 1822, when he proposed a machine to perform differential equations called a difference engine. Differential equations are the mathematical equations which we solve, and they will give us the next result, and these are the equations which are solved in finite times, which can be solved in finite times. So this machine was powered by steam and large as a locomotive, means it has a size of an engine, and this machine would have a stored program and could perform calculations and print the results automatically, and its goal was to output data as printed tables, a necessity for a number of financial, military, government, and engineering endeavors. But the difference engine could not be built at that time, as the technology to produce many components necessary for its functioning was unavailable. Let us see the patterns of equations. First of all, we are going to discuss about equations.
Polynomial functions using the method of finite differences. For hundreds of years, computing polynomials was an important problem because polynomials can be used to approximate a wide variety of more complicated mathematical functions, such as sine, cosine, and the natural logarithm. Let us consider the simple first-degree polynomial f of x equals 2 times x plus 5. The value of f at 1 is 7, f at 2 is 9, and f at 3 is 11.
Like they have replaced x with value 1, so 2 ones are 2 and 5 plus 2 is 7. If I replace x with value 2, so 2 2s are 4 plus 5 is 9, and so on. So this is a repetition of mathematical equations.
F at 4 is 13. Notice that if we take the difference of any two consecutive rows in this table, we always get the same value. In this case, the value 2. A similar thing holds for second-degree polynomials, like f of x equals 2 times x squared plus 3 times x plus 1. Except that now we have to compute two columns of differences before we get a constant value. Polynomial functions using the method of finite differences. We can use the fact that
now what they just did, they calculated two values and they found out the difference between the first and the second value. The results of the first and the second value, that is 15 minus 6 is 9. Then moving on to the third part, then the answer of the third value and the second value gives me the difference between them, that is 28 minus 15 is 13, and the first result that we got is 13. Then they have subtracted the result of the difference which we got after the second equation, that is 13 minus 9 is equals to 4.
The second difference for hundreds of years, computing polynomials was an important problem because polynomials can be used to approximate a wide variety of more complicated mathematical functions, such as sine, cosine, and the natural logarithm. Let us consider the simple first-degree polynomial. We rearrange f of x our pre-computed values into a new table like this. The value of f at 1 is 7. We add the number above each cell and f with the number above is 11, and to the right. F at 4 is 13. Notice that if we take the difference of any two consecutive rows in this table, ad infinitum, we always get the same.
As you can see that they have calculated the results of the difference after the second and third part. Basically, the differences between the first and second values calculated in order to calculate the answers immediately. जो आंसर्स हमें सेकेंड और थर्ड स्टेप में जाकर मिलेंगे वो भी हमें इक्वेशंस के आंसर्स के बाद they were trying to get the results as early as possible in order to consume the time efficiently and finding out the results in the most appropriate way.
Value. In this case, this method is completely general. A similar thing holds for any polynomial for second-degree polynomials. Average's difference engine number 2 contains 8 numeric storage units.
Now the working of Beve's difference engine. Previously it was just meant to give the idea of the equations, how they were calculating the equations, but it is a simple video that how they are going to calculate any result in Beve's difference engine.
Each implemented by a column of gears called figure wheels. The teeth of a figure wheel encode the digit values 0 through 9. Each figure wheel has 40 teeth, representing four identical runs of digits, and the same digit value can be represented by any of the four runs. If a wheel is turned by three teeth, it represents the number 3. Each column contains 31 wheels mounted on a vertical axis, which together represent a 31-digit number. The least significant digit is at the bottom of the column, and the most significant digit is at the top. Negative numbers are dealt with using the tens complement method. Floating point numbers are implemented by scaling. 7 of the columns are accumulators. That is, they contain hardware for incrementing their value by the addend stored in the column to the right. Let's see how that is done. With two wheels, you can do simple addition. If you want to add 4 to the accumulator wheel, you turn the addend wheel 4 teeth. Mesh the wheels, turn, and you get the sum of 6.
Okay, so the next device is Babbage Analytical Engine, and it was invented after 10 years. Then Babbage proposed a more general-purpose computer. Basically, general-purpose computers can handle a variety of tasks, and but they are strong and they're weak in speed and efficiency because they can perform many tasks. Okay, so the analytical engine would use steam for power, have storage capacity of 1000 numbers up to 50 decimal digits, and the ability to process instructions in any sequence. For input, the computer would use punch cards to enter the machine's instructions. Then it also contained a mill with a control unit that allowed processing instructions and output devices to produce printed results. And for this machine, Babbage borrowed the idea of punch cards to encode the machine's instructions from the Jacquard's loom. The loom produced in 1820 and named after its inventor, Joseph Marie Jacquard, that used punch boards that control the patterns to be woven. I will show you the video that will clear the idea. Basically, the punch cards are the papers on which the numbers are printed or the patterns are printed. So, like so many programmers of today, Babbage didn't do a good job of documentation, and his ideas were not widely accepted for the simple lack of communication. Because if I want to convey my ideas or my point of views of new technologies, I should write it down and pass it on to the people who can consider me or who can work on my further research. So he completed 21 drawings for the construction of his analytical engine, but still did not complete the manufacture himself. So in 1991, on the occasion of the bicentenary of Babbage's birth, the Science Museum in Kensington, England, built a copy from those drawings, only finding a small number of very obvious errors. Let us see the video. These are the patterns, and if this is just for the example that how the patterns are woven. This was uh, this was the method which they used in analytical engine. So these are the punch cards which you can see. The tables are printed on which the results we are getting. Basically, it was the idea to get the designs, or these are the punch cards on which we are getting the patterns. Okay, moving on to the next early calculation device, that is Holler's tabulating machine. And here is a figure of that machine. So it was invented in 1889 by an American inventor named as Herman Hollerith, and he also applied the Jacquard's loom concept. And his first task was to find a faster way to compute the US census. What is census? That is in Urdu, which were called as Mardam Shumari, means the population of a country, which should be counted after every 10 years. And it also happened in Pakistan, but these days they are not calculating. So the previous census in 1880 had taken nearly 70 years to count. And with an expanding population, the Bureau feared that it would take 10 years to count the latest census. So, Hollerith machines sense the holes in punch cards, triggering a wire to pass through the holes, closing an electric circuit. And finally, the input initiated mechanical counters and sorter bins and tabulated the appropriate data in usable categories. Means the working of machine. They are telling about the working of the machine, that the they could sense the holes. They could sense the holes, as we have seen in the previous video, that the wires were passing through the holes in the Jacquard's loom concept. Okay, so they are talking about the same thing. So as a result of using this machine, the 1890 census took only 6 months to compile. So in addition to their speed, the punch cards also served as a storage method for data, and they also helped reducing computational errors. Computational errors means the chances of any errors which could occur during the calculation of any census. So Hollerith brought this punch card reader into the business world, founding Tabulation Machine Company in 1896, later to become International Business Machine IBM in 1924 after a series of mergers, and other companies such as Remington Rent and Burroughs also manufactured punch card readers for business use. Um, so both business and government used punch cards for data processing until the 1960s. The Hollerith machines were the first to appear on a magazine cover. Basically, he was the founding member for this purpose. So later on, after his efforts, the business world and used the punch card readers in order to have the data processing easy. This is the video for Hollerith tabulating machine.
The American Constitution's requirement to take a census every 10 years. Starting in 1790, every 10 years the American government has taken a census. The next one will be 2010. Everything was counted: horses, dogs, sheep, cattle, pigs, how many wagons you owned, if you were a railroad, how many engines, you were a ship owner, how many ships you owned. Anything and everything of statistical interest for economic purposes for government planning. What you see here is an 1890 machine used in the 1890 census. A better way of focusing, calculating, and organizing the information. In 1880, the American census took about 5 years to collect all the data. It took another 4.5 years to complete the census. If you hadn't had the Hollerith machine for the 1890 census, it wouldn't have been complete in 10 years. These machines revolutionized large-scale information handling. The 1890 census took about the same time as the 1880 census, even though there were 16 million more people. What did it do? It provided a more organized way and a faster way of processing information. A large data sheet would be marked. It was organized into a matrix. The matrix in turn would be processed so that a punched card could be used. How was the card punched? A machine like this one. An operator would take a look at the data sheet, place a card in here. If there was a mark on the sheet, it would push down, punch a hole in the card. Then you take the card and you put it in a reader. 8 spring-loaded pins electrically connected to the counters on the machine above. You press, put the card underneath, press it down. There was a bed of mercury underneath. Mercury is a liquid metal that provided the ground for the electrical circuit. There was a hole, pin went through, completed the circuit, and the counter would advance. Each counter number being part of the information being collected. Lift the handle up. Where do you put the card? This is an organizer, a sorter, if you will. Pop up because of the electromagnetic relay. The operator would take the card and stick.
Okay, so now I had discussed about other inventors and their inventions. Vannevar Bush developed a calculator for solving differential equations in 1931, and the machine could solve complex differential equations that had long left scientists and mathematicians astonished. The machine was cumbersome, means it was very difficult for the people at that time, because hundreds of gears and shafts were required to represent numbers and their various relationships to each other. So to eliminate this, John V. Atanasov, a professor at Iowa State College, now called Iowa State University, and his graduate student Clifford Berry envisioned an electronic computer that applied Boolean algebra to computer security. What is Boolean algebra? Basically, in mathematics and mathematical logic, Boolean algebra is the branch of algebra in which the values of the variables are the truth values, and that are true and false, usually denoted 1 and 0 respectively. What is mean by that? Computer language works on zeros and ones, so they are working on the logic. For example, if I want to say, if the light is on, so give it the value 1. If the light is off, give it the value as 0. So this approach was based on the mid 19th century work of George Boole, who clarified the binary system of algebra. Binary means language of zeros and ones, which stated that any mathematical equations could be stated simply as either true or false. So by extending this concept to electronic circuits in the form of on and off, Atanasoff and Berry had developed the first all-electronic computer by 1940. But their project, however, lost its funding, and their work was overshadowed by similar developments by other scientists. Now, the above discussed innovations uh, in a period termed as Dark Age or Middle Age of the computers. There are many other scientists and innovations, but they have discussed that are milestones in the development stage of computer. What is Dark Age? Dark Age means the time in which we say the decline of the Roman Empire was occurred. After that, Dark and Middle Ages, the computer technology and ideology improved, and the period was termed as Modern Age of Computing. Now, modern age means the present time or the present world of computer. Now it's activity time. You can play brain games on this link. Okay, you have to do this in your copies. You have to define what were the two machines developed by Charles Babbage. You have to discuss in detail. It's not necessary to write from the book, as you cannot copy the whole text. You can refer to the presentation slides and you can write in your own words. And also you have to describe Holland's tabulating machine in detail. If you want to ask any question, you can discuss or you can ask in class. Jazakumullah khairan. Assalamu alaikum wa rahmatullahi wa barakatuh.